Now, without further ado, I would like to introduce our very first speaker today, President David Zhu. And go ahead, take it away, David.
Thanks, Jasmine. 1 second, let me share my screen. Good morning, everyone, or good afternoon, evening, wherever you are. So today I'll be talking about getting started with Alluxio and Spark for fast data analytics. Since this is the first talk at Alluxio Day today, so it'll be kind of an introduction to Alluxio. But don't worry, if you're already experienced with Alluxio, there will be some interesting use cases for you at the end of the talk. So brief introduction about myself. My name is David. I've been a core maintainer at Luxio for 3.5 years. Before that, I did my PhD at UC Berkeley, AMPLab. That's where the Luxio project and the Spark project were born. And here's my email. Feel free to reach out to me if you have any questions. So at Alluxio, I mainly focus on the performance aspects of Alluxio and also work on the job service. More recently, I've been engaging with the community and part of the community team. So you can find me hanging out on the Alluxio community Slack a lot. So feel free to chat with me, and if you have any questions, feel free to ask them in the community channel. This is a brief outline of today's talk. So first, I'll give an overview of the project, and then I will try to convince you why running Spark on Alluxio is a good idea. I'll give 3 reasons of why you should run Spark on Alluxio, and dive a little deeper into data locality, which is a key reason for using Alluxio. And at the end of the talk, I'll go over several successful production use cases. They're spanning different industries, and hopefully they'll give you some ideas of scenarios where you would want to use Alluxio. First, I'll briefly introduce Alluxio, the project. So it started in 2013 at the AMPLab. Originally, it was called the Tachyon project. It was started by HY, who is now the Alluxio CEO. And in 2 years later, a company called Alluxio was founded to commercialize the open source project. And we've attracted several top VCs from the Valley. And Andreessen Horowitz has invested in us. And our goal is to orchestrate data at memory speed for the cloud for many different data-driven apps, such as big data analytics, ML, and AI. Over the years, we've won several awards, and all of these couldn't be possible without our community. So we have a very fast-growing open source community so far. I believe these numbers might be old, but we have over 1,000 contributors and over 5,000 GitHub stars. We're licensed under the Apache 2 license, so you don't have to worry about any copyleft issues. And here's our community channel, and we always welcome any kind of contribution to our community. It doesn't have to be source code level, even like a bug report or sharing your experience of using Alluxio is extremely helpful to others in the community. Here's just a kind of a list of use cases that we found over the years of different companies using Alluxio. As you can tell, it spans a very wide, very different industries. You can see a lot of technology, internet names here, cloud providers, e-commerce, as well as financial services and telcos. So initially, Alluxio was created to serve as a caching platform, but over the years we've grown to become this open source data orchestration platform, and we support many different compute frameworks on top of Luxio, and support many different storage frameworks under Alluxio, or what we call UFS. So as you can see here, we have Presto, Spark, all the popular big data analytics frameworks, as well as ML frameworks like TensorFlow. And also for the storage, underlying storage, we support many different object stores and HDFS, of course, which is one of the very first use case, and also a lot of different other popular platforms. So let me give an overview of Alluxio and why you should use Alluxio with Spark. So one of the very first reasons is performance, right? Because it improves I/O with better data locality. What does that mean? So when you're running a Spark job, and when, let's say, use S3 as an example, you're reading a lot of data from S3 and doing computation on that data. So a lot of times this pipeline, because you're reading from remote storage, can become the bottleneck. And when that is the case, if you put Alluxio in the middle, it will dynamically cache any input data and place it closer to your Spark instance on demand. So as you're running these Spark jobs become faster because the data access is faster, and the essentially bring the data closer to your computation. So if we visualize the stack, if you have a data access that's going to Alluxio, you can, and if the data is in Alluxio memory and it's local, you will experience very fast speed, right? But even if you don't have a cache hit in local memory and it's going to, let's say, SSD and HDD, you still have a moderate bandwidth. And if compare that with the case where you have to go to S3 to fetch the data, it will be much faster when you have the data in Alluxio. So a second reason for using Alluxio is it enables data sharing between different Spark jobs. Of course, actually, it doesn't only apply to Spark jobs. It really is enabling data sharing between different jobs, right? So because you can have Spark and you can have other frameworks in your setup, and it will enable data sharing as well. So when you have a data pipeline, because a job is never a single job by itself, it produces some result which is usually consumed by other jobs. So you have these multiple jobs chained together as a pipeline, and the result of first job would be the input to the second job. And if you are using S3 as the storage for these jobs, you need to write to the S3 and read back from S3. So this inter-process sharing is slowed down by the network bandwidth. However, if you have Alluxio in the middle, the result from the first job is going to Alluxio, and it can be read back to by the second job right away, because the bandwidth between Alluxio and Spark is much wider, much bigger. So and Alluxio also does asynchronous or can do asynchronous persistence to S3 if needed. So your intermediate result is still saved to S3, but you can start the second job much earlier because your first job will finish much faster. And there's a third reason for why you should use Alluxio with Spark. which is checkpoint data for resilience. This is a picture of showing like Spark and storage in the same process, right? So when you're using Spark, let's say you're using RDD, your in-memory storage and Spark engine itself is in the same process. So if for any reason your Spark process goes down, you lose the data with it. However, if you're running Alluxio, because you're running compute and storage essentially as separate processes, you have this more of a fault tolerance. When Spark crashes, you can still recover by rereading the data that was in Alluxio. So you're essentially checkpointing your intermediate results as you're writing to Alluxio. So there are several ways you can use Spark with Alluxio, and because Alluxio provide many different APIs for you to consume your data, one of the easiest way is to simply change your file system API, change the scheme to Alluxio : //. So here's an example of that. It involves minimal code change and the user does not have to reason about the logic. And as an example, if you're reading a text file from S3 bucket, for example, all you need to do is change the S3A to something like Alluxio : // with the address of the Alluxio master. And everything else is transparent to the user. So how would you set up the Alluxio to work with Spark, or Spark to work with Alluxio rather? It works with the Alluxio client out of the box. All you need to do is add some class path to the Spark class path. Add the Alluxio client jar to the Spark class path. These involve 2 configuration changes. And we have many tutorials on our website on how to use Spark with Alluxio. So you can take a look there. And of course, if you have any trouble, run into any trouble, please come to the Slack channel and we have lots of help there. So as I mentioned before, we have different ways of using Alluxio with Spark. Let's say you're using Spark RDDs. All you need to do is to read and write to Alluxio is the exact same command line, just change it to Alluxio : //. And you might also be using Spark data frames. It's exactly the same as well. You just need to change the URL. So we did some micro benchmarks with Spark and Alluxio. You'll notice the version here is actually rather old. We've done more recent experiments with Spark and Alluxio as well. We didn't see a very different result. So that's what we are going by with the old experiments. So what we did was we take a single worker in Amazon Cloud, and we compared reading cached Parquet files versus reading Parquet files directly from S3. So we read a 50 GB data frame from S3, and as you can see here, when we were reading from remote S3, it took over 600 seconds. And compare that to local S3, local S3 is faster, but if you compare Alluxio with S3 results, you can see we have about 6x to 8x speed up. That's because Alluxio, you're essentially reading from the same machine from the memory. So of course, micro benchmarks are great, but it doesn't necessarily translate to real life use cases, and that's why I want to talk a little bit about some of the successful use cases we've seen. So a typical setup for Alluxio, using Alluxio in the cloud, is you could have cloud analytics caching, which you deploy Spark and Alluxio and in the same cloud environment. And also a different setup would be the hybrid cloud case, where you have Alluxio and your remote storage being different environments. So one could be on-premise and one could be in the cloud. And Alluxio is dynamically caching the content from a remote storage. In fact, the second case, because your data is even further away from your compute, Alluxio often offers even better result. So first use case I would like to talk about is a leading hedge fund. So they're using Alluxio to do model training, and as you know, like these hedge funds, all their entire business rests on their models, and good models can give them a huge competitive advantage. So they need to do this very often and iterate very fast. However, because data access was slow, it was creating a bottleneck for them. And using Alluxio, these training jobs became 10 to 30 times faster, and the business impact is very obvious because they managed to recover the cost of setting up Alluxio within 2 weeks because because they benefit from better training and faster training. A second use case is a machine learning use case at Berkeley. They're trying to gain an end-to-end view of the business with large volumes of data. However, some queries was slow, and because they have a lot of operational inefficiencies, and access and storage for their Spark queries was slow. And also they run a lot of ETL jobs from storage, so that became a bottleneck for them. After adding Alluxio, they experienced a faster turnaround time on these ETL jobs, and which made their entire machine learning pipeline faster. So you can read more about these use cases by going to these links under the use cases. We've co-authored blogs with them before, and they'll go into much more detail of what their pipeline looks like, and you can learn and see if these pipelines or these specific usage of Alluxio applies in your environment as well. The third use case I want to talk about is Bazaar Voice, which is I think they do online user sort of targeted advertising kind of business. So there, the challenge were the queries were slow and not interactive because they have a remote S3, and after adding Alluxio, their queries became 6 to 11 times faster. The interesting part here is they're using Alluxio both as a read and write cache. So when they're reading from Alluxio S3, they're speeding up that data access, and when they're generating more data, they write to Alluxio first, and it gets asynchronously written to remote storage as well. So there are some references you can take a look, which goes into more details on some of these use cases and some performance tuning tips. So just to summarize, today the take-home points should be, if you want to use Alluxio with Spark, the reasons are these three. It improves your I/O performance with better data locality. enables data sharing between different Spark jobs, and also checkpoints data for resilience. So if you have any questions, come and talk to us. I'm constantly hanging out in the community channel, and of course we're hiring. So thank you very much.
Okay, thank you very much, David, for the presentation and kick the day started. I have here is Jian from our own team, and Jian has been working with David. And take it away, Jian, to see if you've got any questions from the audience for David, please.
Yeah, of course. Thanks, David, for the great talk. I have a question about the write cache case. So basically, you mentioned we can write to the Alluxio and do async through to the S3 for the write cache. I'm wondering, what if we fail in the middle, and is there any like consistency guarantee for the async through case?
It's a very good question. If you fail in the middle, there are two cases where it could fail, right? So if the write to Alluxio fails, then the client is responsible for retrying, and it will get an error saying basically write to the underlying storage failed, and it will need to recover from that. So your Spark job would see that exception. It will be the same as if you're writing to S3 or HDFS and that write had failed. So the compute framework, your job is needs to recover from that. And the second case is the write to Alluxio is successful, but the write to the underlying UFS is experiencing difficulties. In that case, Alluxio will go into this retry mode. So it will retry with exponential backoff, so it won't overwhelm the underlying storage. But eventually, if the UFS is not accessible, then the data will still be in Alluxio, and you will the application will need to recover from that. Yeah.
Okay, thanks, got it. I think, do you think in the case that if we successfully write to Alluxio, but Alluxio server was down, and even more like the whole server, the memory server holding the Alluxio is down, and the file is gone in that case, when Alluxio recovered to the normal state, but the file is lost, in that case, like, would it still successfully retry to write to the UFS?
So there are two ways of writing to Alluxio. You can tell Alluxio to synchronously write to the underlying storage. And then there's also the way of writing to Alluxio and having Alluxio asynchronously write to the underlying storage, right? So in the first mode, if the write to underlying storage failed, the client will immediately receive a failed error exception, and the client can recover or do something about it, right? Because it will know writes to the underlying storage failed. In the second case, where the Alluxio is asynchronously write to the UFS, the application itself will need to ensure the write to the UFS is eventually successful.
I see. Got it. I think that's it. That's all the questions from my side. Yeah, thanks, David.
Cool.